are you today? Good? Good. So today we'll talk about one problem which is called the longest palindrome subsequences. Longest palindrome. So tell me what's palindrome?
It's a word when you spelled it backwards, it's the same.
Can you give me an example?
Race car!
Sorry?
Race car!
Race car and? A race car is a palindrome. Yes, well done. And what else? Ryan, can you give me an example of palindrome?
I know one.
Yeah?
Pop!
What?
Pop!
P.
O-P.
O-P. P-O-P. Yes, P-O-P. Where's my... I can't find the useful. Okay, this is useful. Okay, so what's subsequence? Palindrome, you know the palindrome. What's subsequence?
A subsequence is a sequence that can be divided from another sequence by deleting some or no
Yeah, that's the
elements
definition.
with changing the order of the remaining elements.
Well done. Okay, so A, B, C, D, E is a subsequence. You can delete any of them. So it could be A, C, E. Yeah? You can delete B and D, or you can delete B, C, D, then it becomes A. Basically, you can delete none. When you delete none, it's A, B, C, D, E. Or you delete one or more. Yeah, you can delete one of them. It will be A, C, D, E, or A, D, E. Yeah? Do you get it? But the order should not change. Yeah? So basically, you can erase any characters. Okay?
Yeah.
Okay, so the longest palindrome subsequence, for example, like B, 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 A, B. So yes, you can delete the A.
B. Yeah. B.
You can delete the A, then it becomes the longest subsequent, which is B, 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 B. And then you should give me the answer of 4, because you can find the longest palindrome of subsequent is 4.
4 letters.
And another one, C, B, B, A.
B.
B, B, yes, well done. So it's 2, right? You can delete C and A. Yes?
Yeah.
So how do we achieve this problem? Like for example, like A, B, B, A, C, D, D, E. Okay? So for given this, how do we, what's the approach to find the longest subsequence? Any idea? You know?
B, D, D.
So
That's the longest I see so far.
B, B, D, D. Yeah? B, or A, B, B, A. Yeah? And any other one? Because you can't have E, right? Because there's no the other E, so you need 2 E's. D, D. Yeah, C, D, D, E.
B, C, D, D.
B, B,
C, D, D.
C, D, D. Well done. Yeah, that's 5. Well done. That's good. So 5. So when you have no, do you have any other approach? If you don't, you can always start with one approach, which is what? Brute force. You know brute force. Brute force. So what's brute force? Brute force is try naively as many try as all the possibilities, and then check each one.
That will take a long time.
Yeah, that's a brute force. Brute force approach is very intuitive, right? You can think of any, the first approach to solve any problem should be brute force. Then we analyze how complex it will be. So basically we can brute force, we can find, or if we know how to find all the subsequence, yeah?
Yeah.
If we can find all the subsequence, and then we check if each subsequence is a palindrome, right? Alright?
Yeah.
So checking this palindrome, what's the complexity? Checking a string if it's a palindrome, what's the complexity? If I give you a string B, B, A, I want to find, give me if it's a palindrome. Do you still remember how we're checking it? Yeah? This is really easy, yeah?
Yeah.
So given a string, how do we tell if it's a palindrome? Eric?
You spell it backwards.
Spell backwards, or use the 2 pointer here. Look, is A equals A? Yes. B equals B? Yes. When they meet, then it's a palindrome. And how about this A, B, C, D, A? A equals A? Yes. B not equals D, then we know it's not palindrome. Simple. Yeah, so we have 2 pointers moving towards each other. When they meet in the middle, then it's a palindrome. Okay? So let's complexity of this. How many?
BB.
How many complexity? What's the complexity of this approach? O n, right? Yep. And
B, B, C, D, D is not palindrome.
yeah. And finding the subsequence, generating all the subsequence. If I given a string, I want to generate all the subsequence. What's the complexity? So it basically will be the same as given there are n characters. I want to find. Alright. So what's the given the n parameter n characters? Remember, I want to find. I want to find this cn1, yeah? Picking one out of n, yeah? Plus picking 2 out of n, right? Plus picking 3 out of n, alright?
That's all.
And picking n out of n, right?
Yeah.
And possibly you can picking n out of 0, yeah, which is empty, yeah? Picking 0 out of n is empty. So when you add, remember this combination? Yeah, do you remember? 3 apples out of 5. I want to pick 3 apples out of 5 apples. How many? How many ways I can do it? How many apples? Maybe easier. Picking 2 apples out of 3. How many ways I can do it?
2.
Picking 2 apples out of 3.
3.
3. Picking 2 apples out of 3 is equal picking 1 apples out of 3, right?
Yeah.
And picking 1 apples out of 3, how many ways?
3.
Easy. Okay, so picking 3 out of 5 is 5 times, is same as picking 2 apples out of 5. So picking 2 apples out of 5 is 5 times 4 divided by 2, which is 10. Okay? So look, when you added all this together, this is equations to 2 to the power n. Okay? So the complexity is O to the power n times n. 2 to the power of n exponential is we generate the subsequence, right?
Yeah.
And n is the complexity of checking if the subsequence is a palindrome, right? So altogether the complexity will be O2 to the power of n times n. This is huge, yeah? It's not feasible, yeah? It's too slow, yeah? Alright? So we don't need to do this. We can use dynamic programming, okay? We talk about that. So can you tell me what's dynamic programming?
Remembering.
Yeah, the keyword is remembering. Well done. We memorize. Memorization, yeah? Memorization, memorize. So if I give you a function, dp, yeah? An array, dp. If I tell you dp a, b, this is an array, okay? Two-dimensional array. Store. If this stores the number of the length of the longest subsequence between index A and index B. Okay, do you get it? Okay, so look, dp n, any number, n, what does it equal? dp n, what does it equal? If it is same, dp n equals what? The longest palindrome subsequence, between index A, the left A, and the right A. So it's a single character. So what's this equal?
1.
We're done. Yes, that's what I'm looking for. Yeah?
Yeah.
Yeah, because it's only one character. Yeah, it's the longest. A single character is a palindrome, right?
Yeah.
Yes. Okay. How about dp if A, B, if A bigger than B? Okay. If A bigger than B, this is invalid, right? This is left. This is big right. If left is bigger than right, this doesn't make sense. Then we make it 0, right? If A bigger than B, am I right? Yeah? So this A is the left. So basically, look, Eric. When A is 0, and B is 2. So 0, 1, 2. Maybe 0, 3, yeah? 0, 1, 2, 3, okay? So A is 0, B is 3 here. So what's the... What's dp? What's dp 0, 3 in this case? What's the longest subsequence, palindrome subsequence here?
4.
Yeah, 4. Yeah, you got what I mean, yeah?
Yeah.
Okay, so this is interesting. Okay, so look, if I don't know anything about this, yeah, Suppose I don't know anything about this, and I have this. So I know A equals A, yeah? The index S, the S string, Si equals Sj here, right? So it means that, so look, dp AB, what's the relation between dp AB and dp A plus 1, B minus 1, which is this way. If SA equals SB, can you give me, if these two characters are equal, what's the relation between dpAB and dpA plus 1 B minus 1? If these two characters are equal, what's the relation between dp this boundary and the one? Just move each other, just get rid of these two. What's the relation? How big is this? What's the palindrome here? 2. But we don't know if it's 2, right? This is dp A plus 1 B minus 1, yeah? And this is dp AB. So what's the relation between this and this? There's how many difference? How many difference? It's right there.
0.
Sorry? Why is 0? These two. What? Come on, this equals this. If this is a palindrome, if I put the two same thing at both sides, it will be also a palindrome, right? And what's the difference? Length difference?
-1.
What's the length difference? 2. Yes, of course. I added 2, then it will be 2, right? So if SA equals SB, dpAB equals dpA plus 1 B minus 1 plus 2. Got it?
Yeah.
You see? And if it's not equal, what happens? Yeah? If it's equal, we know it. If it's not equal, what's the problem? Look. If it's not equal, Eric, look. If this is, okay, I'm just writing here, okay? dp. This is very important, okay? That bit. When it's equal. Okay? Then, if SA not equals SB, okay? Look like this. A, B, B, C. Okay? If these two are not equal, so what does it equal? What does it equal?
It equals.
Because these two are not equal, is it equals the maximum of this bit or maximum of this bit? Yeah? There are only two possibilities, yeah? Does it make sense? If these two are not equal, then the length of dpij AB is equal to the maximum of dpa minus 1 and dpa plus 1 b. Am I right? Got it? So look, if it's not equal, dp a b, this is a bit difficult to understand, yeah? Equals what? Maximum dp a plus 1 b and what? dp what? A and what? What's that?
B.
B what? dpAB equals, if they are not equal, if the A not equal C, it equals, it will be dpA A plus 1 B, yeah? Or A, what's this? B minus what?
1.
1, yes. So basically, look, Eric, look one more time, look. If this is not equal, yeah? Then it should be the value of this and this. You see? Do you get it? Shifting 1. Yeah? Got it? Okay, so if this is not equal, and that's it. We know how to solve it. Look, if we know, we want to solve dpAB, yeah? Alright? So we need to solve dpA plus 1 B minus 1 if SA equals SB. This is known, right? Or if it's known, not known, we can solve dpA plus 1 B and dpA B minus 1, which is, we got the maximum, right? Yes? So if we solve this, dpA and B, A from 0 to N, yeah? Exclusive N, yeah?
Yeah.
And B from 0 to n exclusive. So what's the complexity? Time complexity if we solve this equation. On what? There are two, A and B. I want to solve this DPA B two-dimensional array. So what's the complexity? A is from 0 to n, B is from 0 to n. Eric? A is from 0 to n, B is from 0 to n. So if we add it together, how much complexity?
Are they?
N and n, if they are n, A from n to 0 to n, B from 0 to n, what's the combination? What's the combination?
0 to 2n.
Why is add? Why always I want to add? Why not multiply?
0 to n squared.
O(n) squared, come on. Look, for A there are n possibilities. And for each n, I have B, which is n possibilities. So it's A times B, not A to B. Do you get it? It's like a road, remember? You have, when we go from A to here, we have two possibilities. Remember we talked about that, Tesco, yeah? Tesco. And then there are 3 ways coming home. How many ways altogether? There are 2 here. 6 is 2 times 3 is not 2 as 3, okay?
Yeah.
Got it? Because these 2 are quite independent. You multiply them together, yeah? Okay? If they are the same, you add it together. If it here is the same, you add it together. But when you combine 2 things, you need to multiply. The same here, okay? Got it?
What about if there's 3 here and 3 here?
Then 3 times 3. Easy. Okay, so now let's write the program. Dynamic programming. How many ways of dynamic programming?
Lots. Did you get?
How many dynamic programming we can write?
3 or 2? 2.
2.
2.
What are those 2?
One is memorization.
Recursion with memorization, which is called top-down, right?
And
What's the other one?
Bottom up.
Bottom up.
Yeah!
Yeah, okay. So look, define.
Memorization.
Look, define if like, let's say DP. And you tell me what is it, okay? I need to put a S here. This is a string, and then from, let's say A and B, what's missing?
Color.
Okay, yeah. Like look, if A bigger than B, return what? If the left bound is bigger than the right bound, what return what?
0.
0, because that doesn't make sense. If A equals B, return what? Yeah? If the boundary is the same, it's a single character, return what?
1.
1, yes. Okay? If SA equals SB, return what? Remember, the boundaries are the same, and then we move it to each other. Return S what? Return what? DP. We want to call this program A plus 1 and what? Wait, what's here?
B.
B what? A
Minus 1.
Minus 1. And then what's the least result? What's the least between SA and B? Remember we talked about if this, how many more characters can it? What's this? Should I do something here? If A equals B, if the string here A will be B, and then it must be the longer than the A plus 1 B minus 1 by how many characters?
2.
2, yes, plus 2. Okay, alright? Yes?
Yeah.
Okay, then otherwise we can return what? Return DP, the maximum, okay? You tell me, okay? Maximum DP as A plus 1, what? A plus 1. DP as A plus 1 B
B plus.
and DP what? As A
A minus
B what?
B. I won.
Minus 1. Come on. A plus 1, B minus 1. Okay?
Okay.
Okay, that's it. What's missing here? What's missing?
Column.
No. Not me. There's one thing missing. Remember, this is the cache. Yeah. Without the cache, this is exponential. Yeah. We need to cache the value. Yeah. Just put add cache. And that's recursion with minimization, which is top-down dynamic programming. Got it?
Yeah.
Okay, now we write the opposite. Bottom up. What's the complexity, by the way? We talk about it.
O-N.
Why is O-N? I'm not thinking. O1.
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 O log N. O-N. Square.
O-N
Times
square.
2.
O-N times N, okay? Yeah? Because look, A and B. A, the possibility from 0 to N, right? B from the possibility from 0 to N. So you are actually calculating N square values, okay? Roughly in a scale of N square, okay? Because when A bigger than B, we just return 0, we don't care, okay? Okay, now let's do the opposite. Define dp as we don't need the AB here, right? So N, we calculate the length, yeah? If N equals 0, if it's empty, we return what? Return what? If it's a 0 string, if it's empty,
0.
yeah. If N equals 1, we'll return what?
1.
Yeah, because the only one character. Okay, now we need to create a dp array. dp equals, look, 0 times N for in N, range N, okay? So what does it mean? It means that dp is a two-dimensional array, okay? Two-dimensional array. It's an array. There are N columns and N rows. Yeah, it's an array, two-dimensional array, metric. This creates a metric, yeah? Am I? Now I need to fill it in, right? For A in range, because we are starting from we can start it from N minus 1 till minus 1 to till 0 and minus N from A from N minus 1 to 0, and then we need to fill here dpaa equals what? dpaa equals what? A single character dpaa equals what?
A single character equals.
A single character, the parent of a single character, which is what? dpa1, yes. And then we need to, for B in range, we starting, because A is define the left boundary, and then right boundary should be from the next of the left boundary until N, right? Am I right?
Yeah.
So range, what should I put here? A plus 1, right? Yeah? Till N. Okay, and here, now we can say, if SA, look, equals SB, right? Now what should I write? dp AB equals what? This is quite similar than previous one. If SA equals SB, if these two characters are the same, dp AB equals what? Come on! dp what? A what? dp A what? These two characters are the same. What happened? It's more than dp A.
Add 1.
Add 1 and
B minus 1.
and what's these two relations? What's these two? This is how many bigger than this? Come on, I just showed you 2 minutes ago. 2, yeah, add 2, come on. Okay, as, look, as, if it's not equal, then dp AB equals what? Maximum of what? Maximum of what? If this SA not equals SB, so dp AB equals maximum of what? dp what? A what? Add 1 and then what?
B.
Okay, and then what? dp what? Minus 1. Well done. Yes. Okay, so a plus 1b or a minus 1b. Yeah?
Yeah.
Okay. And then return which one? I calculate these two dimensional array and I return dp what? 0? Because I want to get it from the beginning to the end, right?
Yeah.
What's the end? What's the end? You can do n minus 1 or what?
Minus 1.
Minus 1. Well done. Okay, so this is bottom up. So look, compared to recursion with minimization, this is a bit. You need to write a for loop by yourself, right? Yeah?
Yeah.
But for the recursion with minimization, you don't need to, right? Because the computer will just call itself to find those values for you. But now you are actively computing the values by yourself, and then you store it in this array. Yeah. What's the space complexity? We are creating this, yeah? And what's this? Oh what? N what?
Square.
N square. Because look, we are creating a two-dimensional array based on this number n, right? Got it?
Yeah.
Okay, so any questions so far? Okay, you can say bye-bye to people and see you tomorrow, okay? Bye-bye.
Bye. Bye.
Eric, can you tell everybody what have you learned today?
We learned about longest palindrome subsequence.
How are we solving it? Which algorithm are we solving it?
Dynamic programming.
And how many ways of dynamic programming?
2.
2. And what are those?
Top, down, and bottom up. Yeah.
Well done. Okay, see you tomorrow.
Bye.